afternoon. I am Latif sir. Today I will discuss about the first chapter of ISC class 12 chemistry, the solid state chemistry. On this topic, I have already uploaded a video, and this is my second lecture on solid state. In the first video, I discussed about what is solid, classification of solid, and classification of crystalline solids, and unit cell, crystal lattice, and calculation of number of particles per unit cell. Today I will discuss about the crystal system. So what is crystal system? You can see here crystal system. There are about 230 crystal forms which have been grouped into 14 types of space lattice, and these are called Bravais lattice. Now see, on the basis of their symmetry there are 7 different crystal systems. On the basis of interfacial angles alpha, beta, and gamma, and the axis ABC. Generally, a unit cell is denoted or represented by three uh, axes A, B, and C, and three interfacial angle between these three axes. So you can see the drawing. This represent a unit cell, where alpha, beta, and gamma are the interfacial angle between three axes A, B, and C. There are total 7 crystal systems depending on the value of alpha, beta, and gamma and the axes A, B, and C. Let's see these 7 crystal systems. Crystal system, first crystal system is cubic. In case of cubic crystal systems, the value of A, B, and C, that is intercept or axis, all are equal in case of cubic, and the angles alpha, beta, and gamma all are equal to 90 degree. Now second one is tetragonal crystal system. In case of tetragonal crystal system, the axis A and B, that is edge length along A axis and B axis, are same. The edge length of unit cell along A axis and B axis are same, but this is not equal to the along the C axis, that is A equal to B, not equal to C. But value of three angles alpha, beta, and gamma all are equal to 90 degree. And third example is rhombohedral. Here value of A, B, C all are equal like cubic system, but the angles alpha, beta, and gamma are not equal to 90 degree. This is the difference between cubic and rhombohedral. In case of cubic, A, B, and C value are equal, but in and also the angles alpha, beta, and gamma are equal to 90 degree. But in rhombohedral, the value of A, B, and C are equal, but the angles are not equal to 90 degree. Then number 4, orthorhombic. Number 4 is orthorhombic. In case of orthorhombic, the value of in case of orthorhombic, the value of A not is equal to B, not equal to C. That is, the axis, the edge length along A axis, B axis, and C axis are not same, but the value of alpha, beta, and gamma all are equal to 90 degree. Number 5, monoclinic. Monoclinic crystal system. Here alpha not equal to beta, no, A not equal to B, not equal to C, but alpha and gamma value are equal to 90 degree, but value of beta not is equal to 90 degree. Next, number 6, triclinic. Here value of A is equal to A not equal to B, not equal to C. A, B, C are not equal, and also alpha not equal to beta, not equal to gamma, not equal to 90 degree for triclinic. You have to remember these values, because sometimes in exam you will given it will given that the relation alpha not equal to beta, not equal to gamma, and yeah, A not equal to B, not equal to C, and alpha not equal to beta, not equal to gamma, equal to not equal to 90 degree. Then question will A question will be that which class of crystal system. That's why you have to remember these values. You have to write down the corresponding crystal system. The angles, interfacial angles, and interfacial axes will given, and you have to answer which type of crystal system. And the last, hexagonal. In case of hexagonal, A and B value are equal but not equal to C, and the alpha and beta value equal to 90 degree and gamma value is 120 degree. Now Praking fraction. What is Praking fraction? It is defined as the ratio of volume of the unit cell that is occupied by the sphere to the volume of the unit cell. That is, Praking fraction is the volume occupied by the particles by volume of the unit cell, so into 100 degree. So Praking fraction is the ratio of volume occupied by the particles to the volume of the unit cell into 100 degree, 100%. Let us calculate the Praking fraction of different cubic lattice, that is Praking fraction of simple or primitive unit cell, Praking fraction of body centered unit cell, and Praking fraction of face centered unit cell. If the length of edge of a unit cell is a, then what will be the volume? Then the volume of the unit cell will be a cube, because length of unit cell is a, edge length of the unit cell is a. Then as the unit cell is cubic, that's why its volume formula of this unit cell will be a cube. Now volume occupied by the particles will depends on the number of lattice point in the unit cell, because it is varies in defined unit cell. For example, for simple unit cubic unit cell or primitive unit cell, the value of total number of particles is 1. In case of face centered unit cell, the value of total number of particles is 4. In case of body centered unit cell, the value of total number of particles or molecules is 2. So you have to remember the number of particles or lattice point in the cubic unit cell. So the occupied volume depends on the number of lattice point in the cell and on the radius r of the atoms or particles occupying the lattice point. So calculate the Praking fraction of primitive unit cell. In primitive unit cell, this is the figure given. It is a primitive unit cell, and this is the one face of primitive unit cell, cubic unit cell. There are total 6 faces like this, total 6 faces in a cubic unit cell. In primitive unit cell, you have to remember the particles or atoms are are attached to each other along the edge of each face, along the edge of each face. So in primitive unit cell, atom or particles are attached along the edge of unit cell. Here the radius of here the radius here the radius of each atoms is taken as r, and the edge length of the each face hmm, edge length of each face is a, taken as a. So volume of unit cell will be a cube, we know that, and we have to calculate the volume occupied by the particles. So before calculating volume occupied by the particles, you have to know that how the particles in primitive unit cell attached. In primitive unit cell, atom or particle are attached along the edge. You have to read this point. In primitive unit cell, the atom or particles are attached along the edges of the unit cell. That is, you can see r plus r is equal, that is 2r is equal to a. You can see in the drawing, it is written that r, radius of one atom uh, attached with the other radius of other atom. So So R plus R is equal to R plus R is equal to 2R is equal to A. A means edge length of cubic unit cell. So the relation between the minimum distance between the neighboring atom is 2R, which is equal to A. Now in primitive unit cell, primitive simple cubic unit cell, number of particles per unit cell is 1. So volume occupied by particles, as the particles are spherical, so volume will be 4/3 pi r cube. As there is one number of particles present, so total volume occupied by the particles is 1 into 4/3 pi r cube. Now r is 2r is equal to a, that is r is equal to a by 2. So put the value of r. So occupied volume is equal to 4/3 pi a by 2 whole cube, that is pi a cube by 6. So packing fraction is volume occupied by the particles, that is pi a cube by 6 divided by total volume of the unit cell, that is a cube. So into 100. So packing fraction is 52.36% in primitive unit cell. Now face-centered unit cell. You have to remember in a face-centered cubic unit cell, the atoms are attached to each other, or particles are attached to each other along the phase diagonal, as it is shown in the figure. In the figure, in the figure, it is clear that in a face-centered unit cell, the particles or atoms are attached to each other along the phase diagonal. This is one phase of a cubic face-centered unit cell, and the particles are attached along the phase diagonal of the unit cell, but not along the edges. So there is the particles are not attached to each other along the are not attached to each other along the edges, but they are attached to each other along the phase diagonal. You can see, because there is a particle uh, at the midpoint of each phases in case of face-centered cubic unit cell. So you have to, the relation between the neighbors particles in face-centered unit cell is r plus r plus r plus r, that is total 4r is equal to 4r is equal to the phase diagonal of this uh, square of this square. Hmm. As the edge of the square is a, or edge of the one face is a, of each face is a, so edge phase diagonal will be root 2 into a. AC phase diagonal is AC is equal to root 2a, where a is edge length of each face, and particles or atoms are attached to each other along the phase diagonal. So phase diagonal is also r plus r plus r plus r, that is 4r. That is 4r is equal to root 2a. So r is equal to root 2 by 4 into a. Now number of particles per unit cell in case of face-centered unit cell is 4. We know that. So volume occupied by the particles in face-centered unit cell is equal to 4 into 4/3 pi r cube. 4 into 4/3 pi r cube. So equal to 16 by 3 pi. You have to put the value of r. The value of r is root 2 by 4 into a. So put the value, then we will get pi a cube by 3 root 2. So cracking fraction of a face-centered unit cell is pi a cube by 3 root 2 by a cube, where a cube is the volume of unit cell into 100%. So 74%, it is 74.05%. Now cracking fraction in body-centered unit cell. Here you have to remember it, as it is very difficult to show a three-dimensional structure in on two-dimensional page. That's why I have not drawn the diagram of, of body centered unit cell. In body, you have to remember that in body centered unit cell, the particles are attached to each other along the body diagonal of the unit cell. And if the edge length of each unit cell, edge length of each edges is a, then the body diagonal will be root 3a. Okay, you have to remember the body, if edge length is a, then body diagonal will be root 3a. And the as the atoms or particles are attached to each other along the body diagonal, then value of body diagonal also value will be 4r, like in case of face centered you can see r plus r plus r plus r. Here also in body centered also the value of body diagonal will be 4r. And according to the diagram, according to the unit cell, if edge length is a, then body diagonal will be root 3a. So 4r equal to root 3a, then r is equal to root 3 by 4 into a. And number of particles per unit cell in case of body centered unit cell, cubic unit cell, is 2. Now occupied volume by the particles is 2 into 4 third pi r cube equal to 8 by 3 pi into root 3a by 4 whole cube is equal to 4 root 3 a cube by 8. So cracking fraction is 4 root 3 a cube by 8 by a cube into 100, that is 61%. Thank you.